Hello and welcome to week 4 of the Spring 2026 Programming with C# course. I'm Jim Kaufman with Rankin Technical College. So first of all, just want to mention, time does fly, and it's already week 4, and you should all be very proud of yourselves. Especially the new students of the Application Web Development Program. You've made significant progress, in a very short time. In and this we're not even finished with the fourth week yet, but just in a kind of, you're getting close to a quarter of the semester being over. So you've done a lot. You've learned a lot and done a lot of assignments. So you should be very proud of yourself. It's always hard at the beginning, first programming language and that. So you should be very proud. Okay, so as far as assignments this week, um, have a hands-on test for chapters 1 through 5. Actually, that's kind of, I don't even like that we name them through that because sometimes it's not always relevant, but that's okay. So we have a hands-on test, and so actually this hands-on test, the in-person, if you were in person, the way they kind of do it there, I kind of do it differently online, where you got a few days, which please don't try to take those any days. Don't just wait until you get done with that to start your other assignments. Knock that out as quickly as you can. If you were in person, basically they have one day to do it. That's what they're doing today in class. They're doing the hands-on test. By the end of the day, they have to turn it in and they're done, right? But a little different for online at this point. I'd like to shorten that a little bit, but for now, I've always kind of allowed a little bit of a little longer of a time frame, just in case. I know some students work full time and things like that. So I'll go ahead. I'm going to go quickly over the hands-on test. Obviously, since it is a hands-on test, I can't help you with the code, but I'll just kind of briefly go over that. And then the other assignments this week is a Chapter 8 written test, Chapter 8 labs, and there's also a Maui lab as well. And for the Chapter 8 labs, I'm gonna do the same thing as I kind of did for the Chapter 5 stuff. I have some demos, so I'll make those available as well. Okay. So while we're kind of going through some of the uh, lecture demonstrations, I'm gonna kind of just kind of review a few things here and there. It's always good just to kind of revisit some things. Um, so that'll kind of really actually just be part of the lecture and the walkthrough. So, and then I'm going to go ahead. So first here, I'm actually just going to go ahead and quickly go through the hands-on test, and then we're going to go ahead and do the walk through the guide, show you some examples through that. Okay, and then I'll go ahead and do the demo. It's actually more than 3; it's 5. So I'm going to demo the 5 apps. We'll see where we get. I'm not quite sure where we'll get. We might get through everything today. If that's the case, we may not do one tomorrow. Well, as far as the lecture, so we'll just see where we're at. I'm also kind of want to kind of show you about using the debugger a little bit. The more you can learn how to use that debugger, how to evaluate your code and be able to understand what's going on there and see the values can be very beneficial. So, okay. So first, let's go ahead and look at that hands-on test. So here's the hands-on test. So the first thing I wanted to mention, all 3 projects, okay? Because I know we've done this a little bit differently at different times, and there's not necessarily one always right way, or one what's right and what's wrong, but it's asking you to create a single solution. Okay, like we've done that before. We did that on some of those console apps. We created one single solution and added to projects. All right, so the first thing you're going to want to do for this is you want to come in, and the first thing, how we choose like a blank solution. So when you start this hands-on test, create your blank solution first, right? And then once you have that up in Visual Studio, you can right-click on that solution and do Add Project. So you're going to add all 3 of these, right? So you're going to have a distance converter, a letter grade converter, and the lawnmower service calculator. Okay. Um, so as far as these different apps are concerned, pretty straightforward here. Let's see, each one of these, I just want to make sure, haven't looked in this for a while. Yeah, I mean, each one of these is obviously a WinForms, right? So no console apps here on this. They're all WinForm apps. What else? Make sure you follow everything. Just kind of want to review that to a certain extent. And, hands-on tests, labs a little, we're more lenient. Instructors are more lenient on the labs, as long as you did, pretty good here and there. It might take a couple points off for some things. But here, I'm pretty much going to follow this, kind of if you didn't name things the correct way, you're going to lose some points here. Okay. So, we try to follow this a lot more, being a lot more stricter on the hands-on test. So, please follow this. Now, I would suggest when you get done with something, because it's easy to start getting into something, you kind of read through this and you get into something and you kind of, forget a little bit about what's here. So, I would always, when you finish one, where, you think you got everything working, come back in here and review it. Say, okay, did I get all of this? Did I miss anything here? So, but that's about it. I don't know if there's really anything else for me to, you just kind of follow the directions here. It's telling you what to do. Please let me know if you have any questions about the directions. But like I said, I can't help you with the coding on this. All right. Okay, so far, so one thing, yeah, we're kind of skipping some chapters. So we're going to be doing chapter 8 today. And kind of the reason for that is just kind of how some of our assignments, work, as far as we have some assignments that kind of fit together well with certain chapters in this book that aren't necessarily follow how this publisher decided to do it. So we do, we're going to do a little bit of jumping around. I apologize. And it's, it's just not me. That's how we kind of do this for all of our instructors in the program. So for this course here, we're going to be kind of doing a little bit of jumping around here. Okay. So, kind of keep that in mind. So we already did, basically chapters 1 through 5. We're skipping 6 and 7 for now. And now we're coming to 8, right? And like I said, also, I think I mentioned this a long time ago, we're not going to cover every single chapter in this book either. Okay, so there are going to be some chapters we are going to skip. But chapter 8, kind of fun. I think it's a interesting topic. Is arrays and collections. You can do a lot with those. Okay, so basically, an array is a data structure that stores multiple values of the same type. So when you create an array, you're creating an instance of the array class. Okay, arrays use zero-based indexing. So here's 5 different numbers, right? And each one of these, the one at index 0 is the 10, at index 1 is 20, right, etc. Okay, and it's always zero-based. Okay, zero-based indexing, the first element is at index 0, etc. Right? To access the 9th element, you would use, right, brackets 8 and bracket, right? Declaring and initializing an array. So here you're actually declaring this with a size. So for doing this, you always have to use a brackets here. This signifies this is an array, okay? And when you do new int, remember when we talked about objects a little bit? We didn't do a lot. We're going to learn a lot more about objects and classes later, okay, in the course. But when you do new here, whenever you see a new, you think, okay, I'm creating an instance of something, right? New always means you're creating an instance of it. So what you're doing is creating a new instance of an array of type int, right? And here you're giving it five values, okay? So let me actually grab a little bit. I'm going to probably just cut and paste this in here. All right, let me paste this in there. So just kind of want to go through this a little bit. This is the same thing that's in that guide, right? We're defining this as an array, right? This is an array of integers. This is the type, right? You always have to define which type. It could be a string array, an int array, etc., right? We're giving a name, our variable is scores, and then we're using the new keyword, right? So this is saying we're instantiating an array, okay, with 5 elements, okay, of type int. And so here would be, this is how you would manually do that, right? And so obviously it's 0 based, so you would take scores. Once you create it of 5, you can only do 5. So it's always going to start with 0. So it's going to be 0 through 4. And so it's just assigning values to each one, right? So you always have to use the name of the variable, right? Brackets with the number. And so here you're doing all of that, right? And so this should work fine. This is just a quick little console app I have here, and I'm just going to run this. Okay, and so the first score is 85, because that's what you asked here, was just the one at 0, right? At index 0, as expected, okay? Now, like I said, though, if you try to access something that doesn't exist, right? You said this has 5 elements in it, right? So here's 5. Well, if you do one at this is actually, since it's 0 based, this is the 6th element, right? And then the editor here in the Visual Studio, it's not complaining at all. It seems to be happy with this, but this is what's going to happen. And you try to start this, and you'll get system index out of range exception. Index was outside the bounds of the array. Okay. So I'm going to stop that. Okay. So this throws the index out of range exception. So that's important to understand and know. If you ever get that, you know what you did wrong, right? Because the editor's not going to help you in that case, right? So editor's not going to help you with that. All right. So these are all one-dimensional arrays, right? So here's the scores, okay? This one is a string array, right? Same concept here. For string arrays, you can do things a little different. This is how you can initialize values in a string array, okay? So these are string literals of Alice, Bob, and Carol, okay? And then here you've got a decimal array, and so we're using M for the suffix for literals. So if you kind of recall here, is if you don't have these M's here, it will actually, it will treat this as a double. The only way you can, and actually the reason we use M is, I say monetary, but it really isn't true. I think I've said that before. It's money, it's monetary. But decimals are really good for that because they have a better precision. Whereas if you use doubles for, when you start doing calculations and you sooner or later, you might be fine for a while, but sooner or later when you're doing a lot of calculations, especially to do with money and currency, you're going to have some rounding errors, okay, when you use doubles. So that's why decimals handle that better, okay? It has more precise, it's more precise. But the only way you can do it is, you have to state. So by default, like I said, this is actually a double. And the only way you can signify this as being a decimal is an M. And the reason it's got M, decimal's a D, right? So like I said, this isn't really money or monetary. It's really, that's what they used for decimal because D was already taken for double, right? When they use those little letters, okay? So double already had their own called D, and so They just came up with M because a lot of times with decimal, it is monetary. I guess that's kind of what they decided to choose. They chose that far. But, you can still create things with decimals and not necessarily have to be money related. Okay. But it has, a higher degree of precision. Actually, just because I'm kind of trying to do a little bit of a review as I continue here. So let me actually drop this in Visual Studio. So this is good, but like I mentioned, if you make these and you get rid of this, by default, these are doubles. Okay? The only way to signify, so this is going to tell you an error. Literal of type double cannot be implicitly converted to type decimal, right? So whenever you just put in numbers like this, C Sharp's thinking, oh, well, it's the editor telling you, but it's telling you what C Sharp is warning you about. These are doubles. These are doubles by default, right? The only way to state that these are decimals is using the M, right? So once you do this, you change that to a decimal. Okay. So accessing array elements. So here's color. Let's take a look at this one. All right, let me bring up Visual Studio again. Okay, so here we're creating a string array, right? And so we're using these. This is a string literal, so you don't have to use the new keyword in this instance, right? You can still do that and as well, okay? But for string, for literals, right? For string literals, you can do it. This is kind of the shortcut using the curly braces and just listing your strings. Okay, so here we got 3 different colors: red, green, and blue. Okay. And then if you want to get your very first one, you use colors subscript 0, right? Here's colors subscript 1. And so this first color is going to be red. This one's going to be blue. Now, if you want to change, so this is 0, this is 1, this is 2, right? So here, if you do colors subscript 2, you can change the color of that to yellow. So this is going to overwrite blue with yellow. Okay, and here is how you can get a length of your array by using dot length. Make sure you use the uppercase L there, right? So colors dot length. Colors is the name that you gave it, right? The name of your array, and then do dot length, and this will give you the count of your array. Okay, so let's just kind of run this real quick. Nothing exciting here. But the third color is now yellow. I'm just showing you that. Yes, I know that wasn't very exciting, but there are some important concepts here. Obviously, how to do an array with string literals. Okay, and then also about changing a value, right? Overriding a value. And then also this is very handy as well. And you can do this also when you start looping through things. You need to, you're going to do a for loop. You need to find out what the length of that is, right? So that will help with that as well. Right? So rectangular arrays are two-dimensional arrays, right? A rectangular array stores data in rows and columns like a table, okay? Using a comma inside the brackets to separate dimensions. So when you define this, okay, you put this comma in here. And so basically it's kind of what it's saying is there's something on the right of that, and there's something on the, something on the left of that, and something on the right of that. So by you doing this, you're stating that this is a two-dimensional array. Okay, if you put another comma in here, you'd be actually saying is a three-dimensional array. Okay, but this one's a two-dimensional array of rows and columns. Okay, so you're saying here 3 rows and 4 columns. Okay. And here's just another way to declare and initialize an array all in one, right? You can just do straight, and this is an integer array. So you can just do integer, int. You always have to give it a type. And so you're saying, create me a two-dimensional array with the name of matrix, okay? And so then you're putting this all, you can use these literals, okay? So you've got 3 different rows, right? And each this is a 3 by 3, right? This was here, this grid here, it was talking a 3 by 4. This is a 3 by 3, right? So to figure out how many elements you'd ever have in one, you can actually take, so if whenever you do something like this, you think, well, how many elements do I have in my array? You actually can multiply them. 3 times 4 is 12. So you'd have 12 different items in here. In this case here, you've got, by you doing this, right? You've got, by you doing this, you're basically, by you creating this like this, you've got 9, right? All right. Okay. So here is accessing a rectangular array elements. So here your type decimal, right? So your type is decimal, your variable's sales, right? This is a programmer decided a variable called sales. And you can tell since you have 1 comma in here, right? So you know this is a two-dimensional array, right? And you've got here's your decimal literals, right? And as you notice, you have an M here. You have to have these M's here, right? We just looked at what happens when you don't have an M for a decimal. Okay, so this is row 0, this is row 1, and this is row 2. Accessing it. So to access the array here, you're the first one. So you're just getting a value. You always have to set this because this is going to return, when this returns something, right? When this returns something, it's going to be of type decimal. So here you're just saying, give me the value, right? This is the name you're giving it. Give me the value of sales at row 1, column 0, right? So let's look at that real quick here. Let me grab something for that. All right. So here's that example, right? So it gets the value at row 1, second row, column 0, first column. All right. This gets the dimensions individually. Okay. So you can also do this. Get length at 0, right? Get length at 1, returns 2. So it tells you how many rows and how many columns. This is how you can get rows and columns of a dimensional array, right? And so this is just getting the value, which you defined here as row 1, column 0, right? Row 1 is, remember we're 0 base. This is row 0, this is row 1. Row 1, right? Row 1 and, no, well, actually the second row, I apologize. The second row, column 0, right? And that'll be to 200. Value 1.0 is 200, okay. All right. So row first, then column to access row 4, column 2 of an array. Vendors, I don't even know where that comes from, but whatever. Just remember everything's 0 based. Okay, so kind of 2 different loops. two very popular loops to use with arrays is obviously a for loop. So use when you need the index, you want to modify elements or need to iterate in a specific order. Okay. So here to get the, you need to get the index, and way you do that, well, you need to know the length of your array. Whenever you got a for loop, you have to be able to specify within your for loop how many times you're looping, right? So otherwise you're going to have an array you're going to have a loop that's just going to go on forever and ever, right? So here you've got your size of your array, right? So this is going to loop to, as long as until it reaches the length of the array, right? Here it's actually grabbing. Well, this is just an example, but this is how you access different elements, and we'll take a look at that. But here's the for loop is really important when you want to kind of modify things. Like here, you're modifying this element by taking this and multiplying it by 2 and putting it in here. So you're modifying this array. Whereas over here, this for each loop is good when you just need to read each element, right? You just need to like read stuff and display it. You do a for each loop. So you got for each, right? And then you have to do int number in array, right? This is the name of your array, right? This is the name you're giving it, okay? This is the name you give it. You can call this whatever, but this is is the variable that is going to end up getting printed out, right? So let me see if I've got a little example. Okay, so for this, here's an array, right? Array of integers, 2, 4, and 6, right? So we use a for when you need to modify an array or need the index. Okay, so here we're modifying the actual value in memory here, right? So for each one, it's going to loop through this array, and it's going to keep on it's going to add, right? It's going to keep on, it's going to multiply each one, right, by 2, and then put that value back in there, okay? So 2 is going to become 4, 4 is going to become 8, 6 is going to become 12, right? We didn't really print that out though here, did we? We can though. Do that real quick here, and we can just say so we'll take a look at that. And then here, the next one is the for each loop, right? So like I said here on the for each, obviously you just want to do this when you read it. It's cleaner, but you cannot modify a collection, okay? You cannot modify the collection, but if you just want to read things, it'll output 4, 8, and 12. Well, that's because it's already been changed, right? But we're going to look at both of them here. We're going to output both of them, which they should be the same, right? So let's run this real quick. So 4, 8, 12, right? That comes from the for, and then the 4, 8, 12 here comes from the for each loop. Okay. So the biggest thing there, like I've already said a few times here, it depends on if you need to modify or don't need to modify, right? So you don't want to use for each if you want to modify. Okay. So comparing. So obviously when you do a for loop, you need to use the, well, you can actually, probably haven't talked about this much, but I should never assume anything. The I is just whatever you want to give this, right? This is a variable you decide. And sometimes you'll see when you do multiple array, sometimes nested fors, right? You have to use other, you might have I and then a J, whatever. And a lot of times, if it makes sense for it to be, a lot of examples always just use the letters. So you use I because it's incrementing, it's kind of an increment type thing. But, you can call this whatever you want, right? But here I just change everything to J. It's still going to run, right? I is just a very popular variable to use for that, right? Let's make sure it does still work. Yep, and it still works. So just kind of wanted to mention that. And a lot of times use I. But so for for loop, you access the index using an I. And then you can modify the element by using the name of the array and then getting that at subscript. This is what I call it subscript. It's subscript I. So you get that array at subscript I, and you can set a new value to that. Right? Obviously use the for, and then use length. So you always have to designate what how many times you're going to iterate through your array, and so you need the length of your array. For each loop, so you don't access it by index. It's for read only, right? And you don't need to have to worry about getting the length of it before you use it. So, all right. Okay, so let's talk about the array class a little bit. So the array class provides static methods for common array operations like sorting and searching. So here's on the left, here's some common methods: array.sort, .reverse, .binary search, .copy, right? So array.sort sorts array in ascending order, okay? Modifies the original. So when you modify something, you're going to modify the original, right? Array.reverse reverses the order of the elements. So array.reverse, you're passing in the name of your array, and it'll reverse the order of your array. Binary search finds index of a value in a sorted array. Okay, so once you might change your sort order. When you do array.sort, it's gonna change that array based on ascending order. So by default, your array it's going to be on how it was added to that array. Okay, if you do an array.sort, it's going to go ahead and change the order of that, right? So then if you do something with that, right? So it's going to be in a different order now. It's going to be a sorted order, right? If you print it out. If you do array.binary search, right? That'll find the index of the value in a sorted array. Okay. And array.copy copies the elements to another array. So you can have your source array, destination array, right? And the length of your array. Okay, let's look at this a little bit. Here's values. Here we're sorting. Let's just grab this. Okay, so here we designate our array of type integer. We're going to be calling this values, and we're using integer literals, right? So 52819. Obviously, you can see they're not in a sorting order, right? They're just however. So here we go ahead and sort this array. Now the values will be 12589, right? Now we can search for a value. Arrays must be sorted first, okay? The array must be sorted first. And we can go ahead and grab, so 0, 1, 2, 3, 4. Oh, we're searching for the number here in the array. So this will return the index of where it is. So this 5 in the beginning array is actually at position 0, right? It's at position 0. But once we sort our array, right, the index is 2. Position of 5 is in sorted array. Let's just run this. And what happened here? Oh, I don't think really anything happened. We just need to print it out a little bit here, don't we? Five found at index 2. Okay, that's because 1 is at 0 once we sort, right? Here, I don't want to confuse things. So obviously this is at position 0 once we sort. So here's position 0, here's position 1, and here's position 2, right? So this is going to return at 2, right? Index should be 2, which it did. Okay. So always remember, binary search requires a sorted array. You always call array.sort before you do an array.binary search, right? Then you can actually search for that specific value within the array. The null conditional operator, question mark, right? Or question mark array, safely accesses members of or elements when the object might be a null, okay? So it's possible things can be a null, right? So actually you can define an array as being null, right? So let's just kind of take a look at this real quick. So here you run this and, well, we're not caring about actually displaying anything. We just want to make sure it don't blow up because we know this, we just define this as null, right? So it did not blow up, right? It didn't print anything because we're not printing anything. But if we go ahead and get rid of this question mark, now you're trying to access something, right, that doesn't exist because this is a null thing. You're not giving this any values, right, this array, right? And here you're getting some warning signs. You're not getting any errors here, though. But look, system null reference, object reference not set to an instance of an object. Names was null. So you get an exception thrown. Okay. And you can obviously, let me get rid of that. So this is very handy to use, the question mark. This was kind of newly, I don't know at what point, but you know, years ago this wasn't available. This was kind of a you know, say a newer kind of feature that helps protect you against null because you know that was always a big thing when programming that you always kind of had to check for null. First, you do lots of if statements. A lot of code used to have a lot of if statements. If this is not equal to null, then do all this stuff. So you always had to do a test to make sure if something was null. Because if you didn't do that test, anytime something was null, you get an error. So you always had to do an if statement, add a bunch of code, right, just for that. Nowadays, you can just go ahead and use a question mark. So very convenient. Okay, so how it works, you know, scenario array is null, returns null, no exception, right? Scenario array exists, but element is null, right? Returns null, the element's value. Array and elements both exist, returns the element's value. Okay, well, it's talking about adding the question mark, right? Key benefits: prevents null reference exception. Okay, stops further operations if null is found, and works with both value types and reference types. So when we talk about value types and reference types, so when we're talking about value types, we'll discuss this more in you know as we go along. So you know, value types are like when you're creating decimals and doubles, integers, right? These are all called value types, right? Stored as values, whereas you can also have objects, right? So we're creating a array objects. We're using a built-in object that C# provides, right? But eventually we'll create our own objects, right? So we'll create our own classes down the road here. And once we create our own classes, we can instantiate objects of that type of class. And if for some reason that object, that class is null, right? You could get an exception, right? You get the same thing, kind of this null reference exception, right? For an object. So the same thing works that. You use a question mark for both types. If you're using value types, which are like your different primitives like integers and decimals and doubles, right? Or for reference types, which are like objects, right? Where with your objects, arrays are objects. Them are some of the built-in ones, string. These are some built-in objects that C# has. But then also eventually we're going to create our own custom objects from our custom classes that we'll create, right? So if those reference type, and them are considered reference types, they're kind of stored in memory differently, and they're kind of handled a little differently. But you can use the question marks also on the reference types as well, right? Okay, list patterns. So this is kind of a pattern matching thing, right? So list patterns let you match arrays or list against specific patterns of elements. So you use brackets to find the pattern, okay? So here you've got an array of type int with the name numbers, and you're using the literals of 1, 2, 3. And that's always something to make sure you understand that when to use brackets, when to use brackets, and when you use curly braces, right? Use curly braces when you're kind of defining things as literals, right? Brackets are for other reasons, when you're kind of getting an index of something, or in this case, you're matching it against. You're using pattern matching, okay? So here you got numbers, right? So numbers is 1, 2, 3, and here you're matching exact sequence. Numbers is a 1, 2, or 3, console write log, all right? So let's just go ahead and grab this and take a look at that. We'll just do this first one at a time here. Let me pull that up. I did there. Okay. Exact match. So this is basically saying that this is an exact match of this, right? Match with wildcards. Okay. Starts with the number 1, right? And then so these are kind of called wildcards, these underscores here. So you don't have to sit there and actually do each one. It's just kind of a shortcut, right? Match with wildcards. Let's just drop that in there. Okay. So starts with 1. So it successfully did that. And let's go ahead and go to the other one here. So this matches the first and last and ignores the middle. So this will match the first one, right? This will match the second one, or the last one. Now, these are names that you give this, right? Just want to mention that. These are names that you would give. You can call this whatever. This is a variable you decided on, right? So you do var and whatever you want to call this and whatever you want to call this. And then you go ahead and put this in your write line or whatever. So let's look at that. So we're matching the first one, so this should be a 1, and then the last one should be a 3, and you're skipping the one in the middle. And so there you go. First one, last three. And I'm just kind of mentioning this because sometimes you see all these different, what's a variable that I'm creating, what's something that C sharp needs, that it's a special word keyword for what am I doing here? Right, and then I'm going to do just LST on this one and do LST on this one. So I'm just making a point. So these are variable names that you created, right? So and then obviously this will run. Okay. So pattern elements use underscore to match any single element. Use the double period, right? To match 0 or more elements, and the var name to capture a value. Okay, we're going to talk here a little bit now about collections, right? So collections are a little different than arrays. So collections are more flexible than arrays. They can grow and shrink dynamically. There are two types, typed, which is generic, and untyped. Okay. So here, type, so you use this idea of generics, right? And we'll get into this more as we go along, but use generics to specify the data type found in system collections generic. No casting required, compile time, type checking. Don't worry if you don't understand all this. We'll dive into this more as we go forward. But here you're giving this as a type, right, of integer, right? This is using generics. Whenever you see this open and whenever you see these definitions and they have the angle brackets, right? This is kind of using what's called generics, okay? And as time goes, we'll talk about that more and more. But this is creating a list. So the list is a special collection that this isn't something, the only thing that you created in here that would be developer created is the variable name, right? Everything else is, well, you decide what kind of list. This could be a list of doubles or decimals or whatever, right? In this case, or a list of strings, a list of objects as well, right? But this is a list of integers, okay? And like I said, this is kind of the only thing from a developer standpoint, the only thing they're going to give it, right? And this is how you write this. And then you also have to have this like open and close parentheses as well, okay? This is called a type collection. And this one is called an untyped collection. So this store object of any type found in system collections, okay? Okay, so these are all, these are built-in types of within the system. So system holds on to all kinds of different. That's what we kind of use a lot of is what's in the systems class, right? And systems also has collections, right? So this requires casting, and what that kind of means is here you've got an array list. You don't know what kind this is. Is this a string? Is this an integer? You can put anything in items, right? But if you're going to kind of use them, like let's say you've got you put a bunch of numbers in an array list called items, and you're going to want to multiply them together or do some special stuff. You have to actually, at some point in time, you have to tell the compiler, hey, I'm using this type or I'm using that type, right? Because usually when you put something in an array list, you're going to do something with it, right? So this is called casting. You have to eventually, you're going to have to say, we're going to take it from this type and put it into this type, right? Preferred type collections. These are type collections, so these are preferred. They reduce runtime errors and eliminate need for casting when retrieving elements. Okay. So here is the list T. So you can do this like this, and so this is the most commonly used type collection. It's like a dynamic array that could grow and shrink. Okay, you're creating a typed list of integers. right? And then you can have, it has special functions, right? So this is the, obviously the variable that the developer would give it. So scores, then you can use these special methods to add, right? So you can add numbers to this scores list, right? And then you can continue to add things, right? You're not restricted by the size. So at this point, you know, you do an add, you've got 3 elements in here, right? Here you can insert at a specific index, right? So let's say, so it's obviously the first one is going to be at 0, second one's 1, right, etc. So you can insert at a specific index. So you can insert 88 at index 1. You can access by index, you know, kind of like an array, right? So int first equals score 0, right, is going to return 85. Get the number of items. So here it's a little different when you're using this collections, right, as opposed to arrays. So if you recall for counts, we use the name of the array dot length, uppercase L for length, and that would give us the number of items. For a collection, you use dot count, right, uppercase C, and that will give you the amount. Okay, and you also can, it has some other special functions, methods as well, such as remove or remove all. Okay, so remove will remove by value. Okay, remove at will remove at index. Okay, let me see what kind of example. I don't know if I'm just going to grab this. Okay, in here. So we're going to do this. So we're creating a generic list that holds an integer, right? And it's always good to kind of hover over things to see what you're kind of doing. It's very helpful for the learning process. So I'm just going to hover over list. It's telling me that list is of what? A class of system collections generic list, right? And it's using this angle bracket T. So this is doing a type. So this is where you put the type of this in here, right? So in this case, we're putting an integer. You can also do a generic type that could be anything, but okay, but we'll wait for that for a little bit. But in this case, we're passing in a certain type of integer, right? Okay. So it represents a strongly typed list of objects that can be accessed by index, provides methods to search, sort, and manipulate list. Okay. And obviously we're using the new keyword here to create the integer list, right? And this is just creating a new instance with nothing in it, of empty list, right? So we're not having to give it any values. We're just saying, let's create a new list of type integer, right? And let's put, and the name of that variable is going to be a score list, right? And then we're going to add items to that using the dot add, uppercase. We're adding 85, 92, 78, okay? Then we want to insert at a specific index. So at the index, this is at 0. This is going to be at 1, right? And so let's, I guess we could write out here after doing that. Let's see, first score list 0. We can write out the one that's at score list right here. Right. So here we've got score list insert 1. Remember, these are always uppercase, all right? Insert, add, okay, remove. So here we're doing that. Let's see what we're at. So this should change 92 to 88. Let's to removing. It's just, this is just going to tell you the count here. Let's run this real quick. So 88 is what's at 1 now. Count remaining is 2. Because you removed this one, and you removed the one at 0, and you remove the one at 78, right? So you remove this one by value. You remove the first one, right? Okay. I do want to mention here that when you do this, so we started with 3 here. And what this actually does, this does an insert. This doesn't do a replace. I think I might have said it replaces this one. No, it doesn't replace this one. So what this is going to do is this is going to insert a new one at position 1, right? So at position 1, basically here, and this is just going to push this down a little farther, okay? So 92 will still exist. Now it will have 81. So actually, if we did count here, let's just do this. So we'll just do the count at that point in time. So we have 85, 92, 78. We added 1 at 88. Let's just run that real quick. So count is 4, right? Because it actually, what it did is just adds at index 1, add an 88, and it's actually just going to push the other ones, and the other ones will be at index 2 and 3, right? This is at 0, this will be at 1, this will be at 2, this will be at 3, index 3, right? So now you've got 4, right? You did an insert. Then you're coming back in here for these removes, and you're going to remove this. You're removing by value. Go find 78 and remove it. This one says go ahead and remove it at index 0. So it's going to remove, the first one removes 78. The second one here is going to remove the 85. And so what's going to be left is 88 is going to be at index 1 and 92, okay, and 88, and then 92 will still be there as well, right? 88 and 92. All right. Okay. So here's some of the methods of the list collection that we kind of used a little bit. Not all of them. We didn't do contains or clear. But we did an add. This is how you add an item. You add an item to the end of the list. Insert inserts item at a specified index. Remove removes the first occurrence of an item. So if you have multiple, it's going to remove the first occurrence. Remove at, it's going to remove the item at a specified index. Count, obviously, is the number of items in a list, as opposed to an array where you use dot length. For list collections, use count. Then contains will return true. This returns a true or false. So this will return a true if the item exists. Okay, and this removes all, clear will remove all items. Okay. So this one's a little more involved here. This is called a sorted list, right? So on the sorted list, you give it a key and a value, right? So it stores key value pairs automatically sorted by key. So each element consists of a key and its associated value. So here you've got a products sorted list, right? And this is how you instantiate it, okay? Obviously, you're giving it a string and a decimal, right? And that's very common for a key and a value, the key being a string, and then the value being whatever, right? But a lot of times a key, you're going to use a string. Unless, not that you could use a number as well for a key, but strings are kind of sometimes popular for a key. So here you can add a value pairs. So auto sort it by key. Okay, it's auto sorted by your key. So here's your key: laptop, mouse, keyboard. Right. Um, so by default, it's gonna be sorted by an alphabetical order, but auto sorted by key. Right. Key value pairs. You're adding a laptop. So obviously a string and a decimal. String and decimal. Access value by the key. So if you want to find it, you've got the name of your array, the name of your sorted list, not your array, the name of your sorted list, right? And then in the brackets, you put the name, right? And it's going to return the price. So you search by key, right? And it's going to return the value of of that key, which will be the price, which in this case would be the 9999. And here we're just iterating through. So this is a little more complex, I know. So you're actually you have to define what this item is, okay? And what the type. So you have to use this kind of like key value pair here, right? And then decimal item and products, and this will tell all items and all values. So let's just go ahead and drop this in the Visual Studio real quick. Okay, everything looks to compile, obviously, or the editor's not complaining. I shouldn't say compile, but the editor's not complaining. Let's see. We could do this though. The first one's going to should print out the price, which would be the 999, and this one's just going to loop through everything. So let's run this. And so there's that price that it printed out. Then here it's just looping through each one of them, starting with a K, right? K. So this is going to be in ascending order, right? Because we entered it as the first one we entered was for laptop, which is an L, right? Then the mouse, then the keyboard. But since it's going to do it in by the key, right? And since it's a string, it's going to be alphabetically, right? So the first one in the alphabet is going to be K for keyboard, L for laptop, then M for mouse. Okay. So keys don't need to be added in order, sorted list automatically. So when you, if you do it with sorted list like this, right? You use the sorted list, it's automatically going to take care of that for you, regardless of the insertion order. Okay, so you can add more things, you can do whatever. It's automatically going to maintain. It's going to have that in a sorted order. So let's also talk about a queue and a stack. So a queue is first in, first out, right? The first thing you enter is what's going to be returned, right? The first one is going to be, then the second one, right? First in, first out. Where a stack is LIFO, right? Last in, first out. So like a stack of plates, last item added is the first item removed. Makes sense? Yeah. Queues and stacks are very popular within programming also for how memory's handled, how actually when you when you compile things and stuff and it prints out, like if you got an error, usually it's going to be you're not going to see first in, first out. You're going to see the last thing first. Okay. And we'll talk about that more in the future. I don't want to get too far involved in that. But the important thing, though, about a queue, for now, a queue is first in, first out. and a stack is last in, first out. Okay. So, and then here's the different methods for, to add. The add method is NQ, DQ is for removing things, and then it's also, has a peek method so you can look at it, and then the order is FIFO. For a stack, this is kind of similar to arrays a little bit. You got a push, you got a pop, and you have a peek. Okay. I don't want to get too far into that. But collection type comparisons. So let's look at this. We kind of already looked at these. So we had a list. We looked at a list, right? So this is a dynamic array, indexed access, okay? General purpose list, right? A sorted list, okay? Whenever you see a K and a V, this is a key value pairs, right? So key value pairs sorted by index. And always remember when you see these brackets, okay, that's talking about generics, right? This is just a type, right? So you could have this as an integer. You put an integer there, or a string, or a certain other object you might be using, right? Stuff we have done, or eventually we're going to create our own objects, right? And so we give them names, and so we would use a list of those kinds of names as well, right? So this is just saying this can be, any kind of type that you want to put in here, right? So same thing here, any key and value. So here if we looked at that last example, we used a string for the key, right? And what was the other? Was it an integer for the value? What was it there? A decimal, right? So this is our K, right? And this is our T for type there, right? Our value, V for value, right? And then a Q, so you do the same thing here. What kind of type? Your Q could be a thing of integers, it could be strings, it could be other objects, right? Just always remember Q is first in, first out, okay? Processing in order, right? A stack is last in, first out. Undo operations parsing, okay. Array list is untyped. You don't have a certain type, right? Dynamic arrays, okay? It's telling you this is kind of a legacy code, just kind of saying avoid it. This is how you used to kind of do array list, more in a traditional type way. Now that you have different types, it makes sense to describe what type you're using. It makes things a lot easier and avoids errors and problems with that, okay? So a quick reference here. We have an array class. Arrays are instances of the array class, right? Array indexing, zero-based, right? So it's just saying the ninth element of an array. Your array could obviously be hundreds, thousands, whatever in size, but the ninth element is going to be at 8. It's zero-based. Your first one's 0. Your ninth one's going to be at 8, subscript 8. Array length. So to do for an array, you do dot length with the uppercase L. Here's a rectangular array, right? When you use this comma, you're saying this is a two-dimensional array, right? You have one, always kind of look at it, one on each side, right? So here you got rows and columns, right? The access. Two-dimensional array access, you use array and then row column to get, row first, right? The row is first, then the column. To get the length, right? Gets the size of the dimensions. So the idea of for and for each, for you need if you need an index, or you want to modify, all right? If you need an index or you want to modify something in that array, you use a for loop. For each, if you're just looping through things and you're displaying things, it's best, and you can still use a for loop for that. But for each is just a simpler way to access all the items in an array, as long as you just want to read them only, right? And here's just the syntax for each root loop, right? You have a type. Your variable, right? And then your variable in that collection. Array sort sorts arrays in place. No return, don't return anything. It just sorts it. You have to make sure that you sort it before you do a binary search. So a binary search returns the index, and it requires, like I said, a sorted array. Null condition. So there's that null operator, the question mark, right? So this prevents null reference exceptions. So instead of having, traditionally, and, if you go work at some company, I'm sure you'll see a lot of code that will, still maybe, some newer code, but, a lot of times at companies, any kind of a large company, any company has been around a long time, they're going to have a lot of legacy code, right? Code that's been around for a while. If it's not broke, they don't fix it, right? They don't just because there's a new feature, they don't go rewrite all their code. That's not very cost efficient for a company. If it works, usually companies will, definitely make changes if there's security problems. If something in their code's a security risk. But generally, there's a lot of code that's been around for a long time, and so as long as it's working, a lot of times they're not going to change it unless there's a reason to redo a whole application. Then sometimes they're going to upgrade that to a newer framework or a newer version of a programming language, right? But so back, a long time ago, you had a lot of, there's, like I said, there'd be a lot of code. You're going to have a lot of if statements. If this is not null, then do all this, right? You had all these if checks. Nowadays, that you can just use the question mark, right? So saves you a lot of typing, makes things a lot easier. Typed versus untyped. So typed uses what's called generics, where you see that bracket with the T in there, and then you can state what kind of type it is. It's an integer or a string or some other kind of object, right? And then you don't have to cast it. We'll talk about casting later. It's actually you having to, when you just created like a separate array list, like it showed that like an older way, then you have to tell it later on, well, I want to move it from this type to this type, okay? And that's called casting. And we'll talk about that more in the future. For your list collection, okay? For collections, for a list, an add will add it to the end, right? Or you can do a list.insert to add it at a specific index, okay? And that doesn't replace, right? That just adds at that index, and it will push other things, okay? List.count. So you remember the arrays, we do length, right? For a list collection, you're going to do .count. So the number of items, not length, right? A queue, remember, is always first in, first out, and it has methods such as enqueue or dequeue, okay? So enqueue adds, dequeue removes. A stack is last in, first out, and it has methods such as pushing for adding and pop for removing. And then array list is untyped collection, okay? And it's telling you here you should really use list T instead, so you define the type, whereas an array list is untyped. And when you do an untyped one, that's where you have to, later on, you have to convert it into a specific type, right? That's like I was talking about the casting part. Common mistakes to avoid, right? So here it's just, an example of having a sales array, right? Where you're trying to access the ninth element. Well, the ninth element is not at 9, it's at 8, right? The first element's at 0, and the ninth element will be at subscript 8. Oh, okay. I was trying to figure out what was wrong here. So yeah, obviously, yeah, you're missing the M's here for a decimal. So by default, whenever you have a number like this, 1.5 or 2.5, by default, it's going to be a double. Okay. So you have to tell the compiler, hey, this is a decimal, and use that by adding an M, right? because decimals have a greater um, you know, it can handle bigger numbers. It can handle rounding better, right? Better precision. That's what I meant to say. Sorry, greater precision, right? Decimals do, as opposed to a double. Um, so here it's just telling you. Oh yeah, you don't want to use a colon here. I don't know why, but it's showing that, I guess. But basically, for each, you're always doing the in, right? Integer, the name of your thing. Here you got, this can be a different type, right? But it's just telling you to use in for each for an array. Array.size or array.count, right? So you don't use size, right, for an array or count. You use length for arrays. Here's this. Let me see what's different here. Yeah. Oh, yeah. It's just telling you you don't want to do like a double, like, because this is a two-dimensional, right? You've got this one and that one. It's not a single dimension, right? It's two-dimensional array. So in this case, you don't want to define it as like this. It's kind of a common thing. So here's one dimension, here's the other. You have to actually do it like this over here. Just that arrays.sort does not return something. Like, some methods return something, like a count, or, we've already done things where a method will return some values, right? But array.sort doesn't return anything. There's no return type. It just sorts it, and what it's going to do, it's going to actually change the original array, right? Whatever array you're giving it, like here, it's just a values, it's going to manipulate that and change it, right? Sometimes some things you run will actually just change it for your own purposes. That's when it usually returns something, okay? But the original one does not get changed, okay? Only the copy. But array.sort always will change the original one. Okay. And then here it's just showing you don't want to, this is an error here. Whenever you use a list, a collection of lists, you have to tell it what type, right? You have to use the angle brackets to tell it like it's an integer, and you do it like that, right? And then always have to end this in open and close parentheses. All right. I know that was kind of a little painful, but I just kind of want to go through these things. We're not going to use all these things for the test or for the labs, but this is just kind of like your first introduction to these, and you'll learn a lot more as we go forward. Right? So let's go ahead and start looking at the demos. So similar to what I did last week with the Chapter 5 stuff, I'm going to do the same thing here with the Chapter 8 stuff. So I've got some demo applications that are somewhat similar. So for your Lab 1, you have a zip code and a delivery charge, right? And here it's telling you that you should use program must pass all provided unit tests. Let's see, program must store this table in a pair of parallel arrays and use the appropriate loop, okay? So basically it's saying you're going to have two arrays, one of zip codes and one of delivery, right? And we'll see how you can do this and be able to access. Once you know where this is, you'll know where this is, right? Because this will be at index 0, and this will be at index 0, just in a different array, right? This will be at index 1, this will be at index 1. Two separate arrays, though. One for zip code, one for delivery charges, okay? But for me, I'm doing something similar, okay? But not your exact one. So I'm doing a shipping rate calculator. So I got a rate table, I got weights, and I got a shipping rate. Okay. So I'm going to go ahead and demonstrate this one. This is going to be the same thing. I'm using stored in parallel arrays. And so let's go ahead and take a look at the code for that. Now for the shipping rate calculator, it's basically you're entering a weight here. You hit calculate. In a way, this really actually doesn't do a mathematical formula. It's actually just getting what the shipping rate is, right? It's kind of more of a lookup than anything. It says calculate here. It's really more of a lookup. And so we'll take a look at that here. So you got different weight limits, right? 1, 3, 5, 10, 20, 30, 50, 75. And then we have different shipping rates, okay? Then obviously each one of these is kind of associated with this, okay? So, well, in the array, right? So you've got an array of, 3, 6, 9, 10, let's see, 3, 4, 5, 6, 7, 8. So you got 8 things in this array and 8 things in this array, right? So if we refer to weight limits at index 0, we're going to have this. If we refer to shipping rates at index 0, we're going to have this, right? So that we can kind of use, once we know at what point we are in this array, right? We can go ahead and get this one that's associated with that in this array, okay? Because we'll have the same index, right? So this is the first one, like 3 and 899 is the second one, 5 and 1299 is the third one, etc., right? Now in this one here, we actually have this defined up here at the top, which is fine. But actually, this is at the class level, if you recall. We were the reason to put something at the class level, especially when we did things like the heads and tails that I demoed, and you did the rock, paper, scissors. There's multiple times you run the method, you're done with that method, and within that screen, and then you keep adding to it, right? Because every time you click a button, you're running that method again. Things are only available, during that. If you have things within a method, it's only available while the things are in a method, unless you define things at the class level. Really, in this case, it's really not necessary, but we do have them at the class level. So here we're basically trying to parse the weight. So this is coming from our form, right? Our Windows form, and we're taking the text weight, which is what we put in the field, and we're creating a variable called weight for that, okay? Then we have a variable to track if we found a match, bool for Boolean, setting it to false. It's always common to always set a Boolean to false, right? Usually you set something to false and you do some logic until you set that to true, because most of the time that's what you're kind of doing, right? So we're doing a linear search through the weight limits array, okay? So basically we have a weight is what we put in our field. So if our weight that we put in our field, let's pretend that this is a 1. If it's less than or equal to the weight limit at index 0, right? We're going to start at 0, right? We're doing this for the weight limit's length. So we're doing that for the length of this array, right? Starting at index 0, right? So first time coming in here, right? The weight limit 0, well, right, will be this first one in the list, which is a 1. So let's just say we entered a 1 in our text field, right, that we got from here, right, and we put in this variable, right? So now this is 1. If there's 1 or less than the value in our weights limit at I, which starts at 0, the very first one. So 1 is 1 less than or equal to 1. Yes, it is, right? So then what we're going to do is we found our rate limit. We need it, right? And on our label rate, that's what I kind of define that as. We're using our shipping rate, right? Not our weight limits. We're using the associated one in our other array. We're doing parallel arrays, right? So we still have the same I, so we're going to be using what's that shipping rates at the index of I, which is going to be 599. Okay, so let's just kind of run that real quick here. So if I put in a 1 here and hit calculate, it's going to come back 599. Okay. So then we put in another one. So let's say our thing is, what thing we're testing for is it's less than or equal to, right? So whatever we enter, is it less than or equal to limits? So the The first time it's going to be 1. The second time is a 3, right? So it's going to be less than, it depends on where we enter, right? If we entered a 2, right? Then it's going to be less than or equal to 3. So let's just do a 2, right? Yeah, because the first one would not suffice, right? It would not match that because it's a 1. So it's going to actually, we're going to be using the 3 here, all right? For a weight limit. For this one would be a 3, right? Because the first time in, if it doesn't find it, it's going to go to the next iteration. So like when we put a 1 in there, it's going to say, is it 1 less than or equal to the weight limit of 1, right? Because that's what was returned, right? Yes, then it printed this out, said found, and breaks out of that loop. If it didn't find that, so say we said put a 2 here, right? The 2 was here, right? Is that less than or equal to 1? No. So it's going to keep going. It's going to go to the next iteration, and then it's going to go and change this. It's going to iterate by 1. Now our I is going to be a 1, and it's going to look here, right? So let's go ahead and do that. Because the first one, a 2 would not meet that requirement. So it's going to the second one. So let's do that real quick. So here we'll enter a 2. We hit calculate. It's $8.99, right? That's because the first one it didn't match. So the one that's at index 1, right? It did. 2 was less than or equal to 3, right? So then it grabs this one, okay? And we do that. We'll do that all the way through here, right? So if we entered the next one, we'll enter a 4. If we enter a 4, right, it's going to use the one. It's going to test it against this one. It would be true, and it's going to grab $12.99, right, all the way through. Okay, let's just do that. Why not? So let's enter 4. They calculate. It's going to grab $12.99, right? So as long as it's less than or equal to, right? So that was like the third iteration, right, through our loop. The first one was for a 1, right? We entered a 4. The first one, is 4 less than or equal to 1? No. So it goes to the next iteration. Is 4 less than or equal to 3? No. It's going to go to the next iteration, right? Then it's going to say, is 4 less than or equal to 5? Yes, it is. It found that. So it's going to go ahead and set that on here. It's going to use the shipping rates one at the next one, right? At the $12.99, right? And it's going to use that one. It's going to set this to true, and it's going to break out, right? So since we set this to true, when we fall out of this loop, right? Because this loop starts here and ends here. When we break out of this loop, because we found it, it's going to go to the next part of the code to execute, and it's going to say if not found, right? And so when it says if not found, if we found it, nothing would execute here, right? This is only going to execute if this is false. So if it is false, then it's going to actually say the weight limit exceeds 75, and we're setting the color here, right? Now this else, you always have to really, be careful about what is associated to what, right? So this if here is actually isn't really associated to anything but itself, right? We don't have an else. This else is part of this one, right? So it was kind of good about here in Visual Studio. It's got these lines, so you can go right up the line and see, oh, okay, it's associated to this. So this is all about our parsing. So if our parsing didn't work, right, that else was associated with the parsing. If the parsing didn't work, then we would be executing this. We would never even get to our for loop, right? Because we only get to our for loop if this is true. If this failed parsing, right, we put in a letter instead of a number, right, it's going to fall out of this loop. So let's just do that real quick. I'm just going to enter a letter here. It's not going to be able to parse that. Invalid data, please try again, right? So just kind of a reminder on, you got to really pay attention to what's associated with what. And that's what really helps with these lines, right? You can see what's associated with what, okay? So like this else here has nothing to do with the for loop or anything in here. If we actually take this and collapse this, right, it's still there, right? Same thing here. This if statement isn't associate really this for loop at all, right? It's not inside this for loop. It's outside of the for loop, right? This only get executed as long as this stays false. So this is going to be false at the beginning. If it's found, if there's a match in the for loop, it's going to set it to true. If it sets it to true, then this never executes, right? This don't execute because this is only executing if it's false, right? So that's how that works. Okay. So that's all I have for this one. So the second demo here is related kind of close to this one here. So the lab 2, you have night stayed and a nightly price, right? A nightly rate. And then so here what you're doing is you enter the number of nights stayed, you hit calculate, it's going to return the nightly cost, right? And then it's going to also return the total cost to stay. Okay. And then here for ours, that's somewhat similar. It's a parking fee calculator, 1 hour, $5 per hour, right? If you stay for 2 or 3 hours, it's going to be $4 an hour. 4 to 6 hours, 3, and 7 is $2.50 an hour, right? So this one, you're actually really doing a real calculation depending on how many hours it is, right? All right, so let's look at that one here. So here for demo 2, we've got hour thresholds 1, 3, 6, 24. Okay, we have an hourly rates of 5, 4, 3, and $2.50. Okay. So 1 hour or less is going to be $5 an hour. If it's 2 to 3 hours, it's going to be $4 an hour. If it's 4 to 6 hours, it's going to be $3. If it's 7 or more, it's going to be $2.50. So first we're going to parse our our hours, right? Put that in a variable called hours. We're just here, we're initializing an initial value of hourly rate to 0, right? Then we're going to go ahead and loop through these, right? And then so here we've got our hourly thresholds. 1, 3, 6, and 24. So if hours is less than, or we go to the first one, will be subset 0. So if our hours that we entered, right, is less than or equal to the first one, which is 1, right, then our hourly rate is going to equal to the associated parallel array. So basically, if it's this, it's going to, here's going to be our hourly rate, right? It's going to return that one. Then we're going to break out of here. We've already set our hourly rate outside, right? So this would now, it's not 0 anymore. In this case, the very first one, it would set it to a 5, right? Then we're going to come down here and we're going to take our hours, is what we entered in our on the screen. And we're going to do our hourly rate, which was determined right here based on the arrays. We're going to multiply that together and put that into a variable called total fee, right? And then we're going to go ahead and set that on our text, right? So we're setting that as currency on here. Probably would be better to use decimal. You know, things like this are usually okay. Because I know there's a lot of examples that are probably going to show doubles on things for current money and stuff. And a lot of times it's not going to be an issue. Anytime you get into anything very sophisticated, it is an issue. So just kind of want to mention that. So then it's going to go ahead and do that. So you're just looping through each one of these arrays, right? Based on the condition of if the hours is less than or equal to the threshold. So the hours that you entered, okay, is it less than or equal to this? If not, then it's going to keep looping, right? It's going to check this one first. Then if it's not, it's going to check this one. Okay, is hours less than or equal to this one? Okay, if it doesn't, then it's going to move on to this one. If it did, it's going to break, right? If not, it's going to go and check it against this one, right? If it finds it, if it is less than or equal to 6, then it's going to use this one, right? Else, it's going to go to the next one, right? And if it's going to be less than or equal to that, then it's going to use this. Otherwise, it would never get set. It's going to fall out, and it's going to say it's greater than. I guess we don't even have that in here, do we? But it's going to fall out. It's just not going to. It's not going to have. It's never going to break. It's never going to do it. It's just going to go through them, and then that's going to be the end of that. Okay. All right. Let's just run it real quick. So if we do 1, it's going to calculate it as 5. If we did 2, it's going to be hourly rate will be 4, but it's multiplying, right? It's going to multiply 2 by 4 and come up with 8. Change it to 3, it's still going to be 4, right? If we change it to 4, it's going to move up to a different hourly. It's going to go down to a different hourly rate. Now our hourly rate's 3. 4 times 3 is 12. And then 5 is going to still be the same hourly rate. It'll be 15. And then 6 should be our same one as well. All right. So still hourly 3. 6 times 3 is 18. Now we do 7 here. That should go to the lower hourly rate, I believe, which is 250 now. All right. So the same thing. And it's just going to keep multiplying. And then what was our next one after that? Was 12 it? Or was it 24? Yeah. No, 12's the same. It's up to 24, I think. $24 was our max. Okay. So what was different about this one, this demo, as opposed to the first one? Well, probably the biggest thing here is, the first one you just kind of went and grab something, you looked for this and you grabbed this, right? You used 2 different arrays for that first one, all right? But for this one, you're doing the same thing, but after you find it, right? That's what you're using. You're breaking out of that loop. Now you've got an hourly rate. You broke out of that loop. You set your hourly rate on here. Then you go ahead and take your hours that you entered on your screen, multiply that by your hourly rate, that's your total fee, right? And then you're setting that on your different text field, right? On your different label. Not your text field, on your different label. Okay, so that's that one. So let's look at number 3 here. So here's a game database that you're going to be creating for Lab 3. And our demo is an employee directory search. Okay, so here what you've got is what? Let's see. So the same thing here, you got 3 arrays, right? You have the name of your game, right? The company, the price, right? On our demo, on our employee directory search, we've got an employee name, we have a department, and we have an extension, right? So it's going to be 3 arrays, same thing as here. And I did want to mention here, even though this isn't like this is separate, it's just showing you an example where you've got Call of Duty, you hit search, it finds it, all right? This one, it's finding it. This ain't 2 separate screens. This is just 2 separate scenarios. Here's where you search, where it finds it. Here's what happens when you don't find it and you hit search. It's going to go ahead and just return game not found, okay? So this is, don't get confused by these 2 separate screens. You're only creating 1 screen. This is just a different, just showing you the different response, okay? So let me bring up that one. Okay, so basically you enter a search term and you hit search, right? And then it's going to give you the name, department, extension, or not found. So here's our 3 different arrays. We got one of names, one of departments, and one extensions. Okay. So the first thing we're doing is we're coming up with our search term. And so what we're wanting to do here, which is kind of common in applications, is, make sure you kind of change it to the same case, because people enter different cases, right? Uppercase, lowercase, whatever. So it's always best usually just to kind of create everything as a certain case, usually lowercase. So we're taking our text.search, right, and changing that to lowercase. Here on this one, probably still should have done a try, probably should have still parsed this. This is going to be text, but you probably should still checked it anyway. Somebody could enter something special character, drop all kinds, users put all kinds of funky things in text boxes, and so you should always check to make sure it's valid, right? So basically, here's your search term. So you're just taking the text that's entered and you're converting it to lowercase. So search term will not be mixed case, so everything will be lowercase. Here's a variable we're using to track if we found the match. Okay, then we're looping through. We got quite a little bit of a little bigger loop here. So we're looping through our names, right? And we're trying to find. We're searching to see if the names on each part of the array, at each index in the array, contains the search term, right? So we use .contains. Okay, so we're doing the names, which we have up here. So here it's got mixed case. So what we're doing is we're converting this to lowercase, right, first. Then we're using a .contains, right? So that's a special method that's available, right, for strings. And we're doing a .contains, and then we're passing in our search term that came from our screen to see if that can be found within that specific one, right? So when you do this the first time, it's going to go to index 0. So it's going to go to this one, right? And it's going to say, did it find that? So if we just type in the word Alice by itself, or we type in CH08, it should find any of that, right? Just CH08. Does it contain that? Okay. Obviously, when you do something, a little more involved, a little more serious, I guess, a little like a real application, and not that this ain't a real one, but, maybe a commercial quality application you're going to do, because here you can kind of return multiple things, and this is just going to actually, even if you had one of these other ones, if this guy was a Carol Johnson down here, it's only going to return the very first one, right? Okay, you'd have to add some additional intelligence into it, all right, in that case. So basically it's going to say if it contains a search thing, then you're just going to go ahead and found a match. You could display the information, set found to true, and you're going to break out of that, okay? And then, and then the next part that's the for loop. That is for, you got 2 ifs, right? First, you're going to check for if, so you're checking both department and names in this case, right? If department or names, okay, has it, right? Then we go ahead and we're going to use it. So this place, we're just checking names, right? If this doesn't, right, then we're going to check for department, right? Does department include that search term? If it does, you're going to do the same here. Pretty much set everything here. then do true, found true, break out of this, right? You're going to break out of this loop. So what happens if it finds that search term when you check for names, right? If it finds it's going to break out of here, it doesn't even check in departments, right? If it doesn't find it in names, it's going to check departments, okay? Then obviously if it's not found, then it's saying employee not found, right? For your lab, it's game not found, right? Okay. Actually pretty basic. Really all you're doing is, you got a couple of different if statements, right? You're looping through an array. But things are a little different. You're changing it to lowercase, right? Two different places. You're going to first change it, convert it to lowercase for whatever you entered on the screen, right? Then also your arrays that you had defined up here at the top, your names array and your departments array, you're going to convert that to lowercase one by one as you're going through it, right? When you're converting it, it doesn't change the values in your arrays, right? You're just changing it right here for your purposes of this, right? Your arrays are going to maintain the camel case just like they are, right? It doesn't change that. This just is doing this right here as you loop through this, right? So the things, like I said, is a little different, is the two lower. And then also we're using this contains, right? This is a special method on the string class that will test for a contains. So if it contains, this is going to return true or false. So obviously, as a little bit of a review, anything within an if statement has to return a true or false, right? Okay, it has to return true or false. It has to evaluate is probably the correct way to say it. It has, whatever you have in an if statement between your open and closed parentheses has to evaluate to a true or false, okay? And so contains returns, this method is going to return a true or false, okay? So let's go ahead and take a look at that. First, we'll go ahead and add, we'll do Bob so it doesn't do the first one. And then the next one, we'll add a part of a name. Okay. So here I'm just going to type in, I'm going to do lowercase here because, right, we're checking for, we're converting it to lowercase anyhow. So even though we have uppercase for B in our Bob, in our arrays, right, it shouldn't matter. See, it's still found Bob because we return both whatever's in here, right? So even if we did something like this, B, two uppercase letters, right? It's going to take all of this, convert this to lowercase, and it's also going to take this, even though it's displaying, this is displaying this from the array, not displaying it from us moving it to lowercase, right? Changing it to lowercase. When we changed it to lowercase, it was just at that point in time within our loop, right, that we did that. It doesn't really affect the array. So that would still find that, right? Like that Johnson one, right? So if we just did J-O-H, I think was it, it'll find Alice Johnson, even just a partial, because we're using the contains. So does this, right, contain J-O-H, right? Yes, it does, so it returns it. Like I said, for us to do something a little more sophisticated, returning multiple, we have to write it a little differently, right? This is just it's gonna look for it, you're gonna find it. If it finds it, it's gonna, if it's in multiple places, it finds the first one, boom, it's just gonna grab it, right? And that's gonna be it. Engineering here, we just type in, this is just gonna return the same one. Well, we'll do something different. Let me look at our array over here. So let's type in RES for resources. RES, heard search, and it didn't find it. So obviously if it returns something and it's a department, it never found this in names, right? Didn't find it in named, it found it in our department, right? Now extensions doesn't matter because we didn't use that, right? We're not searching it, so it wouldn't matter, right? So if we did something like that, it's never going to find that, right? Because we only searched, we only did a contains on name and department, right? So this is what you're going to do similar in your game one, okay, in that lab, but you're going to be doing it for game, you know, the name of the games, the publisher, and the price, right? Okay. What's the fourth one here? Oh, there's a movie database. Here's a product catalog search, right? So in this one here, you got movie data. The user can search by either the name of the movie or the director. If the movie is not found, the program will display information. Yeah, so very similar here. Okay. For our product search, we got a product name, a category, and a price. Okay, so let's take a quick look at that one. All right, so here we've got our three different arrays: product names, categories, prices. String arrays for product names and string array for categories, and a double array for prices. Here's our search term, very similar to what we did before. All right, Boolean found equals false. So basically, a linear search, we're just linearly searching through parallel arrays, right? So pretty much the same thing here. Pretty straightforward. Same thing we kind of did before. We take our product names, our array, and change that to lowercase. Then we do a contains, and the search term is already in lowercase, right? We already did that, right? Yep. So same thing here. And then we're just, if we find it, we're going to set it to true. We're going to print it out, and we're going to set it to true. We're going to break, right? And then if we can't find it in our product names, then we're searching categories. This is pretty a redundant thing, actually. It's kind of a freebie almost. You get done with the other one. You did lab 3, then you're going to be able to do lab 4. So let's go ahead and fire this up. Let me look at my data up here. So our search term, I'm going to put in hub here, GB, hit search, there we go, it found it there. And it's, you know, putting the category in the price as well. In categories, so like here, like I mentioned earlier, so, you know, if I type in accessories here, let's just say ACC, ESS, whatever, hit search, it's going to come up with the very first one in the list. So it's going to find it here, right? And then it's going to use, because you're using parallel arrays, it's going to find this one, right? That's what I believe it returned there, right? Yeah, the wireless mouse, because that's the first one it found. And we didn't build in the intelligence to return more than one, right? So that's what that would return. Prices don't matter here. We're just doing the categories and the product names. And there it's just saying product not found, right? So pretty straightforward. If you, like I said, you get lab 3 done, it's pretty similar to that. So, or well, almost exactly similar. Okay, and then here is a one where for this one, you're doing a credit card masker, okay, where you're changing, so someone enters a credit card number and you hit mask, then it will go ahead and change and just show the last 4 digits of the credit card number, and then we'll replace the other ones with, you know, a pound sign, right, or a hash pound. So this is going to be, you're going to have to work on this maybe a little bit more than what I have here for a phone thing. This is just doing a formatting, and it's basically taking a number that you're putting in here. It's going to be somewhat similar, right? But instead, you're going to replace things with a, you know, a hash or a pound sign, right? Where I'm not really doing that here. This, you're just entering digits, okay? You're just entering digits and then formatting it, right? So you're gonna have open and close parentheses, right? And then a dash between it, just like a regular number would look, right? So let me go ahead and bring that one up here. Close these other ones out. Oh, I didn't want to do that one. Okay. So this, we don't have anything, we don't have an array. I mean, right? This is really isn't about arrays. This is using strings and some of the methods that are available for your string in their string class. Okay. So first thing I'm doing here is getting the phone number from the screen. Right. Obviously, this would be a good one that probably should have really checked this to make sure that it's valid data, right? Just pointing that out. Digits from the input. So we're looping through each character in an input string, right? So here's our input, right? So this is whatever we put in the box, and we're looping through the length of that, right? Okay. And then so when you take your input and do it like this, right? This will get each character. Okay. So like input.length. So if you put in 6, 10 digits. If you put in 10 digits, right, it's going to loop through each. Length would be 10. So each one would be a digit, right? So this would be the character. So if you type in, 314 area code, you type in 3, right? 3 be the first one here, right? And you're going to keep on going through that, right? Until you get through all 10 digits. Okay. Then you're going to do what? Check if this character is a digit. So you're checking to make sure that this is a digit as opposed to a letter. So obviously you put a letter in here, right? It's not going to, it's not going to be, it can't work for a number. So this doing a char is digit to make sure that the current character, right, looping through each one, is a digit. If it is, it's a digit only equals digit only plus the current one, right? So it's going to take, you start out, it's going to have nothing in it, right? It's empty, right? So actually this is a string. This is an empty string, right? So this is an empty string. It'll have nothing. And you're going to add the current character, right? And then as you go through, you're always adding to digits only. So let's say you come in the first time, it's a 3, right? It's going to, area code 314. So first time in, current character is a 3. Digits only is going to be a 3. Second time in, it's going to be digital. It's going to be a 3 plus a 1, right? Will be 3 and 1, right? And I'll keep adding it until it does all of them. So based on now the format, it's based on how many digits we have. Okay, so as we were looping through here, okay, so as you're looping through here, let's see, here's your 4. You loop through all of that. Once you're done, right? Once you're done with your for loop, then we're going and checking. Is the digits only length equal to 10? Okay, if it does, then we're going to take the first 3 starting at 0, right? Starting at 0 for 3. So it's going to be 0, 1, 2, 3. So it starts at 0 for 3, which is basically 3. Our area code is going to be the first 3 digits right here, right? All right, and then we're going to come up with our prefix, right? Our prefix is this here, right? Our XXX. And then we're starting at 3. So when the number comes in, it's just going to be all one number, right? So we're going to be starting at 3, 0, 1, 2, 3 for 3. So that will account for well, here's the number. So that will account for this, right? So that will be our prefix. And then the last part of our number will be like here's all sevens, right? And this is our line number. And so we're going to be starting at 6 for 4 places, okay? So that's our line number. And then here we're just we're formatting it using our area code plus our prefix plus our line number, right? And we're just putting that in open and close parentheses. All right. This is just doing it if our digits only length is 7, right? So we didn't add an area code, right? So if we didn't put an area code, we're going to format it just like this. So we're just putting a dash in between, right? If it's 11, right, digits, if it's 11 digits, right, and the first one is a 1, right, because there's different country codes. And for the United States, right, the country code's a 1, right? Then it's going ahead and adding 1 to the beginning, and then adding this, okay, if it's 11 digits. So let's go ahead and see this run. So first, let's just do we'll do the area code 314 222. Make it easy. 7777. So we got 3, 6, 10 digits, and so that's going to put in the zip code. If we get rid of the zip code here and do it, okay. There you go. And the other one was what? 11 digits, right? So if we had a 1, 3, 1, 4, so let's make sure we count this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we'll hit the format here. Oh, what happened there? Oh, because I think I had this open earlier. So I had a break point there. That's what happened there. Oh, no, that's actually not working right. That's interesting. All right. Oh, yep, that is an error. How you guys doing that's online with me?
Pretty good.
Please let me know if you have any questions, and have a wonderful day. Thank you.